Welcome to Solutions Studio. This is a free series on C programming language. If you like these videos, please subscribe to follow along with this series. Also, please like and leave a comment and share the video to help spread this series. Hello and welcome to this episode, and in this episode we are discussing about one of the most important functions in reading from files, that is the fscanf function. So I'm sure that you are familiar with the scanf function that we usually use to read from the keyboard, but using the fscanf function we are going to use this function to read from a file. Now let's go and see our example in here. In here I have the file pointer fptr, and fptr is pointing to this file that's going to be opened in the read mode. After that, we are printing on the screen that we are reading from a file, and the headers for the data that we are reading is name and score. And then obviously we want to create two variables. One is a string name and one is an integer variable of score. And then using the fscanf function, we are going to read from this file pointer. The format of the data that we want to read is a string with a space and then an integer, and then we are going to store the data that has been read into these variables, into the name variable and into the score variable. And finally, after that, we are going to print the value of these two variables, name and score, on the screen. And that is how the fscanf function works. It reads from a file. We specify the format of the data that needs to be read from the file, and then the data is going to be read from the file and stored into the corresponding variables. Let's go and see the abc.txt file, which is opened in here. You can see the abc.txt file. It has a name and also it has a score. Now let's go and run this program. And as you can see, we correctly read the data that was available on the file. And that's it for this episode. I hope this has been informative for you, and I would like to see you in the coming episodes. Stay tuned. Hello and welcome to this episode, and in this episode we discuss about creating random access files. Previously, in the previous episodes, we have created sequential files, and every time that we have entered some data into a file using ifprintf or reading using fscanf, it has always been sequential data. And the problem with sequential data is that, for example, in here, if I want to go to Sam and want to read the data for Sam directly, then I need to know the details about these two records before Sam, because if I want to seek my cursor to this third line for Sam, I have to know how many characters are these two records, so I can seek and go beyond these two records and reach the third record, because this is a sequential file, and this is the problem with a sequential file. It's not easy to go to an exact record, because each one of these records, they have taken a different amount of memory and different spaces in the file. Now, for that reason, we want to create random access files, and this will make it easy for us to read specifically the record that we need. In this episode, we only want to create the file, and in the coming episodes, we are going to write into these random access files and manipulate the data into those files. But for now, here we have created a structure of records. This structure has two members, the name of the person and the score of the person, just like this sequential file in here. And then we have created a file pointer. We want to create a random access file.txt, and we have initialized an object of the type records structure with the initial data of name and the initial score of 0. And then we want to create some predefined 10 records using a for loop. It starts from 1, it goes until 10, and it writes into this file pointer. So the data that we want this function to write into the file pointer is the initial data in here. It is this object in here, and we can specify how many bytes each one of these objects should take. And in here, instead of specifying the size statically, we've used the size of operator with this structure, and the size of operator would return the size for this structure, and this is how many bytes we want to allocate for the initial data that is going to be written into the file. And this one is used if we have an array of data that we want to enter into this file. For currently, because this object is not an array, that's why we use a 1. How many elements of the array we wanted to be written to the file. And finally here, obviously the file that is going to be written to. Once this is done, we want to close the file. Let's go and run this program. The program was run successfully. You can see the return value 0 in here. Now let's go and open this file. This file is called random access file. And as you can see in here, that all of this 10 data with specifically exact same amount of bytes has been created for each one of these records. So name, and also the value 0, which is not really visible in here, but the amount of data that an integer would take is basically allocated in this spot for 10 records. And this is a random access file that we have created. Now going on in the coming episodes, we are going to manipulate and write specific records into this random access file. Stay tuned and I'll see you in the coming episodes. Hello and welcome to this episode, and in this episode we discuss about how to write to random access files. So as you might remember, in the previous episode we created a random access file and we initialized all of the values to a default value of an object. In this episode we are going to provide the data manually by the user, and the data that is been provided by the user is going to be recorded on the file, but in a random access style, so that later on when we try to read it, we can specifically read whichever record that we want to read directly. So now you can see here that we have this structure record. It has two members, name and score, and we also have this file, a random access file .dat. So we are saving this file in a special binary format because the function fwrite that you can see in here, this function writes data to the file in a raw type of format. So you can see that the raw data representation is also system dependent. That means that the raw data might not be readable on other systems or by programs produced by other compilers or with different compilation options. So you will see at the end of this program, when we try to open that raw file, we will not be able to read it properly, but we will be able to read it with the proper read functions. Now let's go back to our example. In here we are going to write our data on this file, random access file.dat, and you can see that we have created an object of this structure with some initial values, and after that we are prompting the user to enter the values. Instead of taking the values from here, the user is going to enter the value from the keyboard. We are going to save those records or those values into the name and also into the score of the structure, and we check whether the score is 0 or not, because we have said that if the score is 0, that means that entering the data has completed, and now we can stop the program. So as long as the score is not 0, we continue reading the data, and we will write that data into the file. We will write which data to the file? This record structure, this object of the records structure that was created in here, and also the values were initialized by the user in here. And we also specify how many bytes does this structure takes, and how many bytes it's going to be, and how many bytes is going to be allocated for this record into the file. This is what we have specified in here using the size of operator, and in here we have specified 1. That means that this is only one element. If this object is an array, then we can specify more than one element, but since this is not an array, then we have specified 1 in here. And this is the destination or the stream that the fwrite function is going to write, and it is going to write in the file that we have already specified in here. And this function also returns a value. Usually if the value is 0, that means that the content of the structure has been written successfully to the file. Otherwise, if it's some other value, that means that there was an error writing to the file. And once again, we will prompt the user to enter another name and score, and the while loop will keep writing the data to the file as long as the score is not equal to 0. And once the value of the score has been 0, or the user has entered a 0 value, then the while loop will stop and we close the file. And that's it. Let's go and run this program. We have been prompted to enter a name and a score, as you can see in here in this printf statement. We're going to enter all the data that we had in this sequential file. So 100, David, 200, Sam, 300, Hugo, 400, and Rob, 500. And now it's time for us to stop entering the data, so I will provide 2 zeros. And that's it. The program has stopped writing to the data, and the data has been successfully written to the file. Let's go and check out the file. You can see the file has been created in here, but as we said, the data in this file is in a raw format. So even if we try to read it with Notepad or any text reading program, let me open it in here. You will be able to see that we will get some strange characters in here because, as we said, it is being stored in a raw representation and we cannot properly read it with other programs unless we use some specific functions such as fread function. This is the fwrite function, and the coming episode we will use the fread function to read back the data that we have written in this episode. So stay tuned and I will see you in the coming episodes. Hello and welcome to this episode, and in this episode we are reading back from a random access file. In the previous episodes we created and we also wrote into a random access file, and we got some data from the user and we wrote it to the random access file. Now we want to read it back from the random access file, and you will be able to see that what is the benefit of writing to a random access file instead of a sequential file. That benefit you will clearly be able to see when we are reading from this file. Now let's go and see the example that we have in here, the program that we have. Once again, we have created our file pointer. We are pointing into this random access file .dat that we had created in the previous episode, and we are trying to read from it. Then we have created an object of the records structure in here, and this object has been initialized with some default values for the members. Then the most important is this line of code, the fread function. Using the fread function, we are reading from this fpointer file. We are going to store into this read struct. So basically whatever that is going to be read from the fpointer file, it's going to be stored into this read struct object. And how many bytes do we want to read? We want to read the size of the read structure. Basically we want to read one record, and this is, as we have explained before, this value is usually used for arrays, but in here we're not using an array, so this value is going to be remaining as 1. Now the values that we read from the file, now we want to print them. We want to print the name from the read structure.name member, and we want to print the read.score. Let's go and run this program. And as you can see, we got the first name Elham and the score 100. And you can see in the sequential file, basically we're not reading this file, but we had entered these data into this random access file. The data was basically a replica from this sequential file in here, and it was put into the random access file in here. Now, if this was a sequential file, if I wanted to read not the second record, but rather the third record in here, it would have been very difficult for me because I wouldn't know how many bytes to skip. You can see that David in here, it's not specified how many bytes it will take or it has taken, and also the value of the integer, it's not specified how many bytes it will be taking. For Sam it will be 3 bytes, for David it will be 4 bytes, for another record it will be something else. So that's why sequential files are not good for holding records. Now, using the random access file, we know that each one of those members, they have taken a specified amount of bytes, and using that logic, now we will be able to seek into the specific positions of that file. So in this file, in this random access file, we are going to seek into the second element or the second record that is available on that file. And where do we want to start? The seek set means to start from the beginning of the file and to skip 2 records of that file. Now, after we have seek our cursor to the specific location on that file, we want to read once again. We will read into this read structure, and basically the same thing that we have done in here. And once again, we want to print it on the screen. Now let's go and run this program. And as you can see, in this second time, you can see that the name is Sam and the score is 300. We have skipped the David in here, and that was basically easy for us because we used a random access file instead of a sequential file. If this was a sequential file, we needed to know exactly how many characters have taken or how many bytes this first record has taken, how many bytes this second record has taken, so that we would be able to seek into the third record. But in the random access file, everything is structured, and all of the members, they are going to take the exact amount of bytes, and that's why it's easier to seek at specific locations of that file. And that's it for this episode. I hope this has been informative for you, and I would like to see you in the coming episodes. Stay tuned. Hello and welcome to this episode, and in this episode we specifically talk about the fseek function. This is a function that we can use it to move the file position pointer. So we can put the file position pointer in the beginning of the file, in the middle of the file, wherever you want, or at the end of the file. And basically this is what we can do with the fseek function. In the previous episode, we discussed that how we can read from a random access file, and in that episode we used the fseek function. So in this function I will specifically talk about the fseek function. I wouldn't really cover all the other details that we have discussed in the previous episodes. So the fseek function, basically this is the prototype for this fseek function. First argument is that it is going to take a stream, basically in our case a file stream, and then the second argument that it takes is going to be an offset. This offset can be a positive number, and when you're using a positive integer, the pointer is going to move forward But if you're using a negative integer, the pointer is going to move backwards. And this integer, the last argument in here is where to start from. So we have three options that we can start from. These are already predefined in the stdio.h library, so you can use them readily available. The seek set indicates that the seek is measured from the beginning of the file. The seek current, that the seek is going to be measured from the current location in the file. So if you have read something using fprintf or using any of these other functions you have read from the file, your file position pointer has moved somewhere, and this constant will point to that location. And obviously the seek end indicates that the seek is measured from the end of the file. So now you can see that when we have tried to open this random access file, instead of reading from the beginning of the file, we have tried to seek a little bit. We have used this file, basically the random access file.dat. We have tried to set an offset of 2 elements, basically skip 2 elements in here. And then where do we want to start from? Obviously from the beginning of this file. So from the beginning of this file, we are going to skip 2 records. Now this is the data that we have in the random access file. The sequential file is not the one that we are reading, but the data in here is exactly the same that is available here in the random access file. So that's why we're looking into this file. The first record is for Ilham, the second is for David, and the third is for Sam. And now when we run this program, you can see that we got the result of we skipped 2 records and we directly came to Sam in here. And we can basically do more of this. We can set a 4 in here. We will go directly to the 5th element in here. Let's go and run this. And you can see that we've gone to Rob underscore 500. And that's how the fseek function works. If you want to know more about how this program works, we have explained this program thoroughly in the previous episodes, so you can refer to the previous episodes. And that's it for this episode. I hope this has been informative for you, and I would like to see you in the coming episodes. Stay tuned.